connecting. All right. Okay, I'll kick it off. So last week we picked this as um the hottest paper at the time. I would say this is kind of like a I definitely feel like there haven't been as many new hot papers. This might be an argument for us to do like test of time paper club because we can't always do, the paper that was published next last week, we'll cover it this week. Um, anyway, so this one was a survey paper. Basically, these guys read 400 papers on post-training and produced this nice chart. Um, and I, uh, everything here is nice. And then like I think the LLM layer to classify each one of these as a single particular category of like why they're outperforming seems a little bit forced, but I don't know. It's a pretty graphic. Okay, so um, I'm going to start off discussing the paper by not discussing the paper by actually discussing this other blog post that came out recently. Um, and mostly it is talking about like why, there's so much focus on post-training now. This paper is basically diving into reasoning post-training. And I think it's almost like stage one and two are kind of solved problems, and now the only thing left to do is scale up. Stage three is still at the position where like techniques actually still matter. Um, and there's still reasonable upsets when you discover new techniques. Okay, and I also thought this was kind of interesting and relevant. I think it'd be really cool to be able to add a column and kind of browse through the paper and extract stuff. This is how illicit should basically work. Um, um, what else can I comment on here? I didn't have much else to comment. Oh, sorry, I just opened the chat. Um, Eugene says it's surprising how the fundamentals full trips full up. Yeah.
Oh yeah, I was just in support of Vivu's test of time idea.
Yeah. I mean, we talk
I,
about it, but then always we do the hot paper because it's hot.
no. We're doing second paper club. We're doing test of time. I'm putting together curriculum. I'll share details in Discord
Yeah,
this week.
I think the curriculum will be
Yeah.
the bulk of the value.
I think Swix has a list, right? You created that in December.
Yeah, yeah. But he may want to
We'll tweak.
make different choices. Yeah.
Okay. I'll let you know if anything in chat is important, but
Mm,
just yap
yeah.
for now.
I mean, so I think this is kind of old schoolish in terms of like you have RL methods and then you have fine tuning, and those will mostly track like the major hyper params of what's going on for each of these models. But I can't shake the feeling that this is like almost going to be out of date. Um, anyway. This is the first major explanation from this paper. So basically, we're going by charts, but then also you can sort of use this as a menu of like, do I know about this terminology? If you don't know about it, you can double click on it. They probably have like a 1 to 2 paragraph explanation of it, which is kind of cool. Um, this paper basically I like it when papers break down side by side things that are introduced independently. So, for example, if you read the PPO paper, um, you will have one view of the world. If you read the DPO paper, you have one view of the world. And it takes people like DeepSeek and it takes papers like this one to just put them side by side in the same framework so you can kind of compare vertically across them and see how they might differ. I definitely think like they should probably use more um, of a color gradient or something to indicate which is an LLM. Or yeah, like which parts of models. Because I think like here it doesn't really capture the distinctions between DPO and RLHF. It doesn't really capture distinctions between GRPO and all the other guys. Um, Let me see if there's any comments here. Okay, Robert. Um, Okay, Robert has an interesting comment. I don't know if the pre and post training distinction is super clear in the context of these reasoning models. Like one thing they mentioned is using test and scaling and generate high quality outputs to supervise train on. Yeah, all that is post training, right? So you can go back here. Pre training, you should be only doing it on large, very, very large corpuses, and your only job is to get the perplexity down or the loss down. Um, on the predicting the next word. Um,
Do you have like a like is that the kind of boundary between pre-training and post-training? Like,
yeah, there's a famous Karpathy chart. This is a window into how I index things online. Um, there we go. See, so quickly, my access is very, very quick with anything Karpathy related. Um, Pre-train is trillions of words and then thousands of GPUs, right? Anything beyond that is like in the hundreds of Ks in terms of data sets. So like not even comparable. You're like three orders of magnitude off. Uh,
yeah.
yeah.
But in terms of the intention, it's just you have a small set of data that you really want to index on.
Um, I don't even use those words. The in vogue thing that people say now is behavior elicitation. Um, Pre-training loads the model with a ton of different behaviors, and the fine-tuning or post-training process will elicit the behaviors that you want to select for. Uh,
Mm-hmm.
why I have a negative reaction to what you just said is that you are overly focusing on the data. Um,
Mm-hmm.
let's say, and like that is the opposite of what you want. So you actually want to generalize beyond your data. So it's a slightly subtle point in the fact that you are trying to provide some data that kind of vaguely points towards the behavior that you want, and you wanted to just take the hint and keep going.
Mm-hmm.
Whereas the thing you just said was something like, focus on this data set. That's kind of you probably want to generalize out of domain, at least as far as the foundation model lab is concerned.
Okay. I might need to think about that a little bit more, but I think another like way to think about the
Very
question.
a
Go
very
ahead.
simple. Let me cut you off a little bit I just thought of another one. Um, these guys will happily provide more math data sets in order to in the hope that it will generalize to broader reasoning.
Okay.
So they like, yes, obviously it'll do better on math because you gave it more math data sets. But the idea is that you're eliciting behavior that has more reasoning, just because you use math to do it.
Yeah. I think what I was going to say is that maybe where I was getting tripped up is the distinction between the intention and the technology. So, like, if you're just doing supervised training, supervised fine tuning, the like actual implementation details of what you're doing are maybe not that different from the pre training stage. Then there's this sort of reinforcement learning techniques that are a little bit different.
Yes, these are
But
all
I
very
think what
different.
you're talking about is the intention. So that's kind of separate from the like actual implementation of what's happening.
The intentions kind of show through with the choices you make. Um, but yeah, sure. Yeah, absolutely. Um, I was just trying to reacting towards the data focus that you had. Okay, Tyler Cross, what do you say? Reading the V3 technical report, like thought they broke down the costs. Yeah, okay. I mean, this part of the DeepSeek stuff, this is almost certainly a psyop. They know that reporting last run numbers is meaningless. Um, Anyone who knows anything knows it's meaningless. That's why we always report total GPU hours. Um, yeah. Is this last run? Actually, no, this is all of it, right? Huh.
It's last run.
Oh, it's last run. Okay, well, there you
It
go.
is that they say in the text of it that it is last run.
Yeah.
I have
Uh,
a video where I back into these numbers in a spreadsheet.
oh, can you drop that video?
Yeah, yeah, sure. I can drop the spreadsheet too. Give me a
That'd be
second.
cool. Now the fun question is, Dario on his blog,
10 mil is all you need.
Dario on his blog leaked some alpha on what Claude Sonnet cost, and it's not clear where is it? Where's the quote? It's not clear. Oh God. Yeah, there we go. Claude 3.5 Sonnet is a mid-sized model that costs a few 10 Ms to train. Which one is this? What number does this refer to? It's unclear.
Also, a few 10 million. This is quite a range,
I mean, 5, right? Plus minus 2. It's in the ballpark.
But that's not the final run. Sorry to interrupt. I don't think that's the final run. So that tens of millions, and there's a screenshot from a talk given by somebody at OpenAI. I think it was Noam Brown that said ChatGPT was like 50 million. So, and let me find you that spreadsheet. But yeah, that's more likely the closer to the final number. Like Dario's number and the DeepSeek paper number are what I call apples and oranges. They're not like measuring the same thing. Is my interpretation of it.
Totally fair. Honestly, like when you're in the business of raising like $4 billion, this is just like whatever. Okay. Yeah, well, feel free to drop the spreadsheet when you find it. But I'm just gonna keep
I
going.
just dropped it.
Yeah. I think is there anything interesting in these slides? I would say that I would highlight that obviously GRPO has gotten a lot of attention. When I originally read the DeepSeek math paper, it seemed like they were saying that these are all kind of equivalents. If you read like DeepSeek math, and they introduced GRPO, let me show you the exact chart that they blah blah blah. They had some like ablations of like different things. They were like, okay, like it's good. No, actually, I don't think this is it. This is what I'm looking for. Okay, they have some other ablations. Maybe it's in the R1. Maybe it's in the V3 paper. I don't know. But nope. This one. Sorry. Let me just. I'm pretty confident I can find it quickly. This is why I'm persisting even instead of giving up. Why did they release this on GitHub? This is super annoying. Okay, I can't find it here, but there's ablations showing that like at the time they were like, okay, this is like kind of equivalent to the others. This is the more helpful way to do it. But for those who are members of the Discord, you can just type in GRPO. I've been keeping a track of a lot of GRPO explainers over here. And I definitely think it's kind of emerged as something that people are focusing on for improving your efficiency of training, right? I think the main knock on PPO is that it's like models everywhere, and you just need to. There's a lot of data that you just have to chew through it in order to get anywhere useful. Whereas DeepSeek is all about efficiency. Okay. Let's catch up on the chat. All right, Ishan has dropped his spreadsheet. Yeah, actually, Ishan, is there anything you want to talk through? I don't know if there's anything.
Go to the second tab, and I just use the number of flops to back into the estimate and come up with a MFU, the model flop utilization. You see on line 16 of
That's
about
so low.
17%, which is a little low, but it's within reason. That's the only part that like you take the number of flops and you can use that to calculate based on, because the entire thing is very fixed. It's not even a calculator, it's an equation, right? It's a giant equation, so you know how much compute was needed in theory. And that number actually looks pretty low given all their efficiency. That's the only thing that seems a little odd, but that is a reasonable number from compared to other models that I could find proof points for.
Okay.
I can walk through the whole thing if you want, but I don't want to sidetrack us because we're talking still about this is all pre-training. And this is supposed to be a post-training conversation or topic, but I'm happy to go through the details, or you can also just watch the video where I do it.
Yeah, I would say that let's just send people to the
Yeah,
video.
we can move on.
But appreciate always the knowledge drops.
I
And
think I have a slight comment regarding the flops thingy. Is it because it's the H800? Because it's just memory bound rather than compute bound for the DeepSeek side.
Maybe we sidebar in the chat. I don't want
Okay.
to tangent us too far.
okay. I mean, you know, sidebars are fun. I don't like I said, I don't think I'll take the whole hour. This was weird. I did spot this in the chart where they start talking about episodic memory agent, whereas everyone else is like kind of reasonable techniques that you're familiar with in the literature. I don't know what the hell episodic memory agent is. Yeah, I didn't really look it up. Yeah, okay, this is only mentioned in figure 2. So I feel like they just made this up and stuck it in there as a hallucination test just to see if you're awake. Anyway. Okay. This is a further deep dive into the optimization techniques. I definitely think like some high level familiarity with these are good. Like this chart is I think the probable top 3 that you should be familiar with. And I don't know what else I can say about that. I think like what the overall lesson that I've understood is data efficiency is king because alignment data is very rare, or like human annotation data is very expensive and you have to get as much mileage as you can out of it. So even though for example at the prevailing conversation at the time of the DPO paper, which is maybe like half a year or a year ago, was that it was probably worse than PPO, but because it got rid of one of the models inside of the PPO toolchain, it's just that much more efficient to train there, and therefore you could just get a lot out of it. Okay. I'm just gonna keep going unless people have comments on GRPO stuff. Anyway, so like there's all this like this is all prelude to R1. They had obviously there's been a lot of explainers of R1 in the last few days, in the last couple months. I would say that they had a pretty decent I guess like one-page explanation of the RL stages for as far as summarizing the R1 paper. I would definitely go through that if I mean we already did an R1 session, so we don't have to. But I think that this kind of is something that Ilya has maybe mentioned in the sense that there's always this cycle in ML where you tack on like increasingly complicated things. To some extent, this is the opposite. You start with the complicated one and then you try to look for ways to simplify. But and then you find the self-play pure RL approach and that wins. So we have an article on what Ilya saw. And I remember this one was very interesting. So he had this is a direct quote from an email that Ilya wrote back in 2016 when they were founding OpenAI. He said that we realize self-play in multi-agent environments is magical. If you place agents into an environment, no matter how smart they are, environment will provide them with the exact level of challenge because they're doing self-play, which can be faced only by outsmarting the competition, which is again a clone of itself. So, for example, if you have a group of children, they'll find each other's company to be challenging. If you have a collection of super intelligence, they will also compete with each other. The point is self-play is king. And I think that's what R10, obviously AlphaZero, also discovered. Self-play lets us get something out of nothing. The rules of a competitive game can be simple, but the best strategy for playing this game can be immensely complex. I think this is really, really insightful. This last sentence. Basically, the rules of chess are simple, but then the strategy for playing chess can get really complicated. And I think that is a really powerful insight that it makes me think that a lot of this doesn't have to exist as long as we had the right, reward function or whatever. Um, and I definitely think like R10, found a little bit of that. Obviously, that's not everything that we need for R1. Um, but R10, I think a lot of people say that, it's more profound than R1 itself because R10 is just like did the pure thing, which is really cool. Okay, there seems to be a lot of chat in the things. Eugene is talking about some training stuff. Okay, we're doing post-training. All right, let's keep going. Um, Obligatory LoRa and fine-tuning discussions. I don't know what this is doing here, apart from like, I guess these are important parts of the ecosystem to know. Um, this part of the paper felt very much like they felt they had to include this, but it's not really post-training. This is just PEFT. And then there's then you put that alongside of deep speed, which is like a completely different part of the stack. So like this one just felt weird. I don't know what this section of the paper was trying to do.
Why do you say PEFT and LoRa is not part of post training? Like, if we look at Apple Intelligence, bunch of LoRa adapters and base model, they use that as a form of post training, right?
It's
Like
not
task
post-training.
specific.
It's not post-training in the sense that any of these guys use PEFT.
Throw Apple in there. PEFT.
Yeah, I don't know. Um,
Phi also, Microsoft Phi is now PEFT. They do LoRa's.
it's okay. So you pick the two worst models in the whole set.
Train on benchmarks is all you need. For Phi, you train on benchmarks to look like you know what you're doing. For Apple, you train on benchmarks because that's what your users care about, and then you ship 3 years later.
Yeah, it's great. Good strategy. Um, all right, I'm gonna keep going because I didn't super like this part of the paper. Test time scaling, very cool, very hot. Um, I do think that this is probably a decent set of things to know. I actually never really thought about sequential revision being a thing, but like actually this is what I think about when I work on ChatGPT Canvas, which so I'm default pro this. This one looks completely out of place. Compute optimal scaling is chinchilla. I don't know what it's doing inside of here. Um, maybe I don't know, it means something else, but like I feel like this term is overloaded enough because that's the exact title of the chinchilla paper that they should probably use something else if that's what they're trying to say. But I will keep going on in terms of, so I think that um, chain of thought, obviously it's like something that we have known works. I think that there's this period of like a year and a half that everyone is doing like skeleton of thought, tree of thought, graph of thought, whatever of thought. Um, and it was all just minor iterations on like, oh, let's search thoughts in different ways. For those who are keen to catch up, we actually did a paper with the Trio Thoughts author, who now works at OpenAI on the reasoning. Um, yeah, I would say like I think that this is worth including, even though I think it looks so low tech or it looks so basic, because the original chain of thought was just let's think step by step. That was the prompt, and that improved performance a lot. But I think like in some ways, the fact that we can distill DeepSeek R1 into Quen, into Llama, and still do enormously well, that is just like sparkling chain of thought. I like it. I don't see how fundamentally it's any different, which is like very disturbing that we took this long to get there. I don't know if people have any comments on this part of like the chain of thought distillation. Nope, silence. Okay.
Sorry, what was the question? The
Isn't
chat
it
was trying.
weird? Like we've known chain of thought was good for a long time. And how come we took like 2, 3 years from the original chain of thought paper to roundabout discover R1, blah blah blah, and then finally be able to use thinking models, quote unquote thinking models, to
Yeah.
distill into non-thinking models, but suddenly they're a lot better.
I think
Yeah,
there are
go
two
ahead.
factors for this. Yeah, so like I think one of it was like I think there was a Facebook paper that was very early on saying that you can distill chain of thought, and everyone kind of knew that. But another factor was that when chain of thought started being used, right, the general consensus and opinion of using chain of thought for evals was that it's a it's not a good way to do the eval. And there was even debates about it early on, even within Immutable AI and a few other eval communities, that if we allow chain of thought evals to happen, it would basically people would just like go longer and longer chains, and then how do you measure one model after another? Obviously, all of that went out the window when OpenAI said this is the new standard. So it's really that moment that really changed the perception, because it's like, oh great, this model can only be evolved through chain of thought. We don't have a choice now. And I think that was the forcing function. For a lot of times, people didn't want to, at least within the eval community, and that didn't give the incentive. I suspect that was the case.
Oh, that's fascinating. I was actually going to do a post or a blog on this, but I have a Twitter thread I'll drop in, where I've been collecting various posts from folks on why they think it emerged right now. That the one Eugene mentioned is really fascinating. Like, we were just not evaluating it this way. Some people have said the models were not powerful enough. There's one guy who 2 years ago, he said 2 years and like every 6 months, I think he tried doing R10 and it never worked for him. And he's got a whole thread on what he thought. There's another one from Ross Taylor, who was Meta's reasoning lead, why he thinks it works now. And another one, I forgot her name. Vogel is the handle. I'm sure a bunch of you recognize her. She had a theory that basically there's chain of thought data leakage into the training of models today. And so now they had some hint that we can now elicit or summon out of the model that wasn't there before. Those are like the three most popular theories I've seen so far. I've been collecting them in this thread. If folks see others, let me know. I'll add them to that. But I've wondered a lot extensively, like, how did we miss this? It just seems crazy.
Yeah, it does. I that is likely to be all we get. We just wonder.
Sorry, can I ask one thing? It's from my understanding, these techniques are really reliant on this like verifiable like math problems and stuff.
Yeah.
As in be scored by an oracle to do RL. So I wonder if there's any like just the data has accumulated over time to the point where the RL works where it didn't before.
I think it's a bit of a mix of things, right? Outside of just RL, I think you also need a good base model. Like, the base model has to be able to be at some level of intelligence to do this self play. And up till like, yeah, 2 years ago, we were optimizing for like inference time, but now, or sorry, for train time. But now, like, starting from base llama models is when there was even ability for people to start replicating some of this stuff. So like, first we kind of had that shift, right? Models are now kind of overtrained to be good base models. From that, they reach a base level of intelligence that the self-play and all these tricks start to work. It's like even with the Claude Pokemon thing, 3.5 Sonnet would not play Pokemon at all. It would get nowhere. 3.7 can. There's just like base level little like frontiers of, this is the next stepping stone. So as much as people tried this sort of RL base model, was just not that good a while ago. Like, yeah.
Yeah, 3.0 Sonnet sucked. Okay. Question from Bing. Is there any info on how much COT data was used to train DeepSeek and its distilled models? I think they like said like the rough number, and that was all we get, right? Yeah, I wouldn't search that. I mean, you can search the R1 paper. Suffice to say, I don't think we have much info on the data set.
They said a little bit of how many samples, like 800,000 samples, how much SFT and then RL they did. I don't remember these numbers off the top of my head, but they say how many SFT to RL and stuff, but they don't tell you how many like pre-trained tokens. But they have a little bit. 600 reasoning, 200 general, but that's what someone says. 800K samples, but that's I think the distill models, but it's something.
There's so again in the Discord we have the R1 thread. Let's see one. Okay. There's a better chart with all the data sets kind of visualized. Let me see, where is it? Wow, we have a lot of. Nope, here it is. Okay, here. Yeah, here's all the data sets. So 600 here, 200 here, but then also there was like this SFT stage. Oh, I guess it was just combined. Okay, got it. Yeah. Oh, there you go. Okay. Yeah, I mean, the thing I was going to highlight was verifiers. I guess we already. So like, I guess the thing I was going to push back on Robert on was the fact that like we've always had the ability to do these verifiers. By the way, OpenAI calls it graders. They're going to launch this in a GA format by the June World's Fair. And I think like basically this is the what Will from the New York Summit is working on is basically the open source version of whatever OpenAI has in-house. So I think it's important. I think it's but like I think the other tricky thing is like we're very unsure how this generalizes. The hope is just like you do better at coding and math, and then suddenly you're just better at like writing poems. I don't know. It's very 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 big as to like how this actually improves reasoning. More like beyond just the domains that it specifically is evaluating. Yeah, I don't know, but like it's a way to generate more data for free. Yeah, so why am I focusing on verifiers here? Because it's down here. I would say this is kind of the single hottest place in the post-training stack right now. Because everything else seems like relatively scoped out, I would say. Now it's just literally doing this stuff. Cool. I don't know if there's any other comments, but I'm about to be basically done. The paper kind of ends by doing this like really opaque classification of the 400 papers that they did the survey paper on. And everything's just going up and to the right because the general field is going up and to the right. So it's a little bit hard to tell what's going on. I think it's a little bit ironic that MCTS was the biggest spike, only to find that obviously MCTS, according to DeepSeek, is not useful. It sounds like the other frontier labs have also agreed that yeah, we also found that and we just never reported it, but DeepSeek did. So that is the oh actually no sorry I think I was talking about process reward modeling. I mean both of these were sort of poo-pooed in the DeepSeek paper, and that's very sad for the state of research. You cannot use raw numbers of papers published to estimate how much how rewarding a field is going to be to actually do research in. Yeah, and I think that's the paper summarized. I would say if you needed a place to start and like understand which terms and which papers to look up, I think this is a very good summary of the state of the art. It might actually be a better use of time to look at Sebastian's work, because he only focuses on like 10 papers, and does a little bit more explanations. But you will miss some stuff. So this one is does a much better job being an actual survey paper than Sebastian, and they just have different goals. Cool. Akash says, I'm a guy who is new to this and wants to learn how reasoning works and more about RL. Do you think I just find classic RL and then come to RL applied on LLMs? Okay, modern approach. Okay. Looks like people are discussing there. Yeah, I don't know. Any other like open questions that people are interested in? I think this is like a decent survey. But also I'm clearly like not wowed. But I mean I do think it's a decent survey.
So one question I have is current test time scaling approaches that are used in like, the leading edge models, are they mostly just use more thinking tokens, or is search like still a big component of that?
Zero search and inference. We're not sure how much search there is for generating. So okay, if you look at here, right? This is a form of search. This is not search, but like you can do whatever you want in the pre-trained synthetic data generation process, including search, and then rejection sampling of the search, right? Over here, by the way, yeah, I think they have good definitions of all these things, right? So if you want to understand like beam search, rejection sampling, all these things, like you can do that. And but that is the synthetic data stage. And um, that does not apply in inference for sure. We do not search during inference. I think a lot of people, right up to the release of O1 and maybe a little bit beyond that, were like, oh, surely Strawberry has to have it. Q star. Q star has to involve some kind of search because of the Q star algorithm. And that was a complete psyop.
Yeah. So one question I asked in the chat that I was trying to figure out is whether there's a value function that we get out of the generative model as part of GRPO. And I think the answer is no. So it's difficult to map that to like the AlphaZero paradigm AlphaGo paradigm where you're using like MCTS and you're like sampling the trajectories that you take based on the policy itself. But it sounds like that's not something that's actually needed in the final like reasoning model.
If for inference, yeah. I'll definitely say that.
Yeah.
Eugene is talking about Atari and Q learning. Yeah, I mean, like Q learning, honestly, it's one of those things where it's like a form of abstraction that you're like, I don't know if this adds any value, and then you're like, and then you find that it does, and it's kind of a mindfuck because now like nothing makes sense anymore. You just have to put things in black boxes and hope that it works.
Yeah, maybe I'm old school, but I think that learning about Q learning and policy and value iteration really helped me understand and grok what was it I was trying to learn and how discounted rewards matter. It's clearly a little bit divorced from what we're doing in LLMs right now, like DPO and PPO and all that. But I thought it was really fun.
Yeah. I think you and I we did this during the
Oh,
Georgia
MSCS. Yeah.
the Georgia Tech thing. They covered this in OMSCS. I don't know. Like in some extent, in some way, like PPO is like a kind of similar thing. Um, I don't know if
With the KO constraint.
yeah, I don't know if going through this
And
helps at all. I honestly I don't know.
yeah. Yeah.
Xiaobai in the chat says, does 1B beat 405B papers, just PRM model and still be helpful as a small language models to achieve great results? Sure. I don't know. Now the harder thing is the 0.1B. Actually we have Eugene on the call. What is Blink doing?
He's just working on the 0.1B for the RWKB7. Just lots of experiments on it.
Yeah, so isn't that more interesting than 1B? 0.1B is better.
It's interesting. No, it's fun, but the only reason why I'm always having lukewarm on it is that every time we launch a 0.1B and then we just show that hey, it can create funny and interesting text, it gets viral, everything is great, and then I see the usage numbers and no one uses it. Everyone
Well,
just like, okay, we'll use the 1.5B.
this is the first time I've seen it. You mean there were previous attempts?
Yeah, so our previous 0.1B is coherent as well.
Oh, okay. Well, this is the first time it's actually reached my attention. I didn't know about the previous ones.
So I think the big shift is this is the first 0.1B that we did with thinking token.
Right.
So there you go.
Thinking tokens are all you need, man.
Yeah.
By the way, yeah, if you look at the verifiers code base, I was just kind of browsing through it. It's kind of cool to see. You see, go look at the prompts to how you format these tokens. You can just kind of do this. You have this like XML parser where you have a reasoning field and an answer field. So now all the data that he generates will be just wrapped in a reasoning field, and then the answer field will be wrapped in the answer. And so that's how he's doing his data generation. And it's kind of cool. I never really, I would never have resorted to an XML parser to do this. I would have just have created some text, but you know, whatever you need to do your little angle brackets, that unlock so much reasoning.
Also, if people really like 0.1B models, right, there's also an entire subset domain of like this more specialized use case. Like we have a 0.1B Sudoku solver. We have and I think like there's another 0.1B previously just more like a Go player, like Go game. It's quite impressive like how far you can push the reasoning plus like doing a small game essentially.
That does make sense. Cool. Shabai says distilled. Yeah, okay. This is a classic question of I think that, so let me make sure that people can see it on the recording. It's a classic question of like, given the same amount of data, is it better to train a large model and distill down, or just train a small model and go as much as possible? And the answer is train a large model, distill down. We don't super yet know why, but this is demonstrated enough that it just is true. I think it is a little bit the PPO effect again. The fact that you train a model and then you sort of like preference reward models are some forms of distillation anyway. So yeah. Okay, wait, we have to interrupt this message for doggo report. Vibu, where is your doggo? Wait.
Doggo is playing. Mochi, come here.
Okay.
Doggo is coming. Coming.
Oh,
Coming.
Mochi.
Coming.
Wait, his camera died. Okay, never mind. All right, no doggo.
Oh no, Doggo is paper clip. Doggo. Good
Was
girl.
up for a while. Yeah.
Good girl.
So that
She's
is
a good little paper clip.
doggo is all
This
you
is
need.
new paper club Doggo. Learn it to Doggo. Learn it to girl. Girl. It's Uncle Wang Wang. Good girl. Good
This
girl. Okay,
the bow tie is unnecessary, man. What is this?
it's her leash. It's her leash.
Oh, okay. Oh,
They
okay.
sat for like an hour like this yesterday. Okay, you're listening on paper. Get that pre-train first.
See, we are now energized by the doggo. Yeah, Eugene says teacher-student paradigm just works and is increasingly adopted in Rexis too. Oh, is there some Rexis literature for teacher-student?
Yeah, a ton actually. I'm trying to do a review right now and hopefully publish it something by end of this week. But there's been a lot of papers whereby training a teacher model that just and then you just distill the teacher labels into a student model. It just works super well. The paradigm of pre-training and transfer learning and distillation is increasingly making its way into Rexis.
Okay, we'll have a deep research. Ah, fuck.
I'll share with you this one paper. I think I have like 4 or 5 papers covered, but this one is a good explanation. whereby they found that using a teacher model, even if the teacher model is just two times larger or 4 times larger, and then just distilling that the teacher's labels into teaching the student, it just works super well. If you open a PDF, I can guide you through the image. If you scroll down a bit, yeah. So auxiliary distillation, right? Those are you're learning on both the hard label. The hard label is the actual ground truth, and the distillation label, which is the label from the teacher. So by learning that, right, the model just able to learn better. I don't fully understand why, but empirically, I found several papers that actually apply this, and it works. So, and then if you scroll down a bit more, I think in figure 3, they show how now the teachers are very expensive, right? So what they do is they have a single teacher, a single big fat teacher, and then you distill a lot of the labels, and then you use all those labels to teach all the different students. So maybe the teacher will be learning on, I think this is YouTube, the teacher will be learning next best video, home feed ranking, I think like profile ranking, etc. We'll learn all on the combined data, and then we'll distill a lot of soft labels. And then you have individual student models. They can either be LoRa's or individual small models themselves that both learn on the hard label and the teacher label. I think the benefit is because teacher labels just give you a lot more labels. I think a big part of that is that where teacher labels just help you address the data sparsity issue. But I'm still trying to grow why actually it works. So look out for that.
Nice. Yeah, very, very cool. I wish I had more time to spend on Rexes.
Oh, you don't have to spend time. I can do a survey paper next week
Yeah,
or the week after once I publish that thing. Yeah, if you guys are interested in survey, Rexes.
we actually had a talk submission from Instacart for the New York Summit for LLM driven Rexes. And we actually rejected it. But I think there's a good talk to be done at some point, and we haven't had one of those in AI engineer yet. So let's see. Okay. That's it. I didn't have any other content prepared. Maybe like I was thinking like maybe you fill the time with Gemma 3. But I mean it's just Gemma 2 but better. Um, it's like
I always thought that the Gemma series were interesting that they don't give us long context. Like I think Gemma 2 is 8K context. I haven't checked Gemma 3, but like
oh
Google has the like
this one is 128.
oh okay, never mind. I take it all back.
Yep. They're catching up.
Google started the long context and then they had TPU and they actually served million context, but they wouldn't give us our open source long context.
Yeah. I asked the spicy question on the Hacker News thread for Gemma 3. Where is it? And they were like ask us anything, right? So and then I was like, okay, fine, I'll ask you anything. And then the question was, will there ever be a Gemma 3 thinking? How copyable is Flash thinking to Gemma series? Nothing we can announce. I think it'll be awesome if they can just if Flash thinking is such a portable thing that they can just port to Gemma. Because then you have Gemini Flash thinking at home. Like this thing
They could also just give us Flash thinking. Flash is small.
yeah, exactly.
Like I think there's a case for both, right? Like you want a thinking model and you want a non-thinking model. In this case, a dense 27B. So you give both.
I mean you can also just like distill R1 into Gemma 3 and see where that takes you. Yeah. Anyway. Yeah, I mean it's like not super insightful. Like a lot of these are just evals. So that's unfortunately the state of papers today. It's just they don't really tell you much apart from just evals. Yeah, cool. Shall we call it? What's next week's paper?
Next week, any volunteers?
I don't know, maybe you might just have an emergency paper club based on GTC or something.
GTC papers?
Oh, I just got invited to this Q&A session with Jensen.
Oh, are you attending?
Yeah.
Are you hosting?
No, like we got this like media ticket, so they're putting us in like their regular sort of media circuit. I don't know. I've never been to GCC, so I don't really know what to expect.
Neither have
Very
I.
exciting.
Maybe I'll see you there.
You're speaking, right?
Yeah, it's a small panel with Chip. It's right after Jensen's keynote, so I don't even know if people will attend. But yeah.
Well, it's a free trip. Why not?
Yeah, it's a free ticket.
Okay,
Unless you can come say Dago.
let's
Yeah,
do
exactly.
yeah, very important to acknowledge Doggo. Okay, let's do two questions and then we'll call it a day. Andre says, what does the next iteration in context window length look like beyond Gemini Pro's 1 to 2 million window? Any opinions, people, while I draw up my answer? Here's the answer. I mean, there's two answers, right? One is ultra long context, and two is infinite context because you are doing some kind of recurrent thing like RWKV.
On this, right? I have a question and I wanted to ask poll the audience here. So imagine you are trying to run a query on the latent space blog. So latent space blog, let's assume that it has 1 million, maybe 2 million tokens, probably more than that. Would you still use RAG? Or would you just fit everything in there? And this is not a debate of whether RAG is dead or not. Is that, using RAG, you have to evaluate retrieval, you have to build retrieval pipelines, retrieval as latency. Whereas you can just remove the entire part of that by just putting everything in a context. What would you do in this day and age? Extrapolating, 6 months from
Is
now,
cost
12
part of the
months from now.
question?
Of course, cost is part of the question. Development cost is part of the question. Evaluation is part of the question. Quality is part of the question. But cost is just getting lower and lower, no? Latency is getting lower and lower. And by putting everything in there, because with RAG, you may retrieve different documents all the time. But if you put everything in there and it's sorted by time, then you have prefix caching, right? A benefit of that is prefix caching. So would you still use RAG? I have my take, but I want people to debate.
I think we still need to evaluate hallucinated answer, right? Just because it's in context doesn't mean that
Yeah.
you're guaranteed that the output is correct. So some of the benefits there are not the same. There's little optimization, like shorter prompt instead of the 100 million context will be faster, but drag is useful. Other takes.
Yeah, I have a different view now. I'm starting to develop a different view whereby, I'm working with teams, they are building all these RAG pipelines, they have all these data structures, all these retrieval pipelines. And sometimes it's for very short context. And my thinking is really, just put everything in there. It's like even if it's just 200,000 tokens, therefore that way you don't have to allocate time to evaluate retrieval. You don't have to build, you save all the effort of building the retrieval because you're just taking everything in there. You're guaranteed that the information is in there. If you're just taking everything up to a point in a movie, up to a point in a paper, up to a point in a book. It's more expensive, yes. Latency is a little bit longer because you have to run through pre-compute and all that is, you have to run through that and that's a loop. But with what Gemini Flash 2 is doing, like Gemini Flash 2, I'm loading in a huge ass text, and I get response in 3 seconds. I think 3 seconds is acceptable, right? And you just don't have to deal with all that finagling and all the evaluation. I think it just greatly simplifies the structure now.
So I tested a lot of this in the medical domain where we really needed really high accuracy and confidence in our outputs. And even though it's a human loop system, our thing was just that we were better optimizing what goes in the prompt than throwing the whole document. So on a performance basis, a better prompt with the core part of the answer was better than long contexting the whole thing. Now we ran a lot of evals on this. The only thing was that there were no reasoning models yet. I have a slight thought that reasoning models can handle this context better since you have steps of reasoning. But we tried a whole array of different prompting techniques, and what we found worked best was just a better concise answer, concise input of what the reference should be, and then
more concise context, right?
yes. So we can't just flood the prompt with garbage, but yeah, I can't rerun this on reasoning. I haven't.
Did you, when you did those evals, did you see any correlation between ruler or any of those other like post, needle, and haystack methods for evaluating long context?
No, we weren't trying to evaluate on context. We were just actually like in production trying to
On your
system
task,
and
yeah.
yeah, on our task. So it wasn't to
Okay.
measure context. Like it was more just so that like we know that the actual source is in there, and it wasn't like adversarial, right? Like we didn't want to try to pull out a sample. We just wanted like you have a reference of something that we know it's in the prompt, but you know how well does it answer? And then as you throw in 3, 5 documents and just get more loose with it, it obviously does worse.
Thank you. One area around this that I've wondered about is in like a legal setting. So if I did RAG on a long contract, I don't know if I trust it to pick out like all the contradictions. Or if I ask, hey, does any part of this contradict itself? Right? That's where I'd feel like I'd want the whole thing and I wouldn't trust RAG and I would throw it into a large context. Especially with, you know, if I could put reasoning on it.
Yeah, we did this with insurance policies, which are also very long and
Oh, yeah.
contradictory. Like if
Yeah.
this is billed as preventative, even though it's covered in this, and even with giving the whole segment and the right retrieval piece relevant to the question, it still did worse than just having this. And like we would just pre-process out our RAGs. Like our RAG was actually just LLM processing. It wasn't even semantic. Like so, like. Yeah, but that's
I see.
sample of one.
So
So-
I want to make I just so I understand better. You found that actually using RAG was better in the policy documents than giving it the entire policy.
Policy plus the extracted portion, like flooding the
Okay.
context was not great. This was also like a
Interesting.
heavy llama post train on llama 2, so models have gotten better, but yeah.
Okay, that's interesting. Sorry, Eugene, I cut you off.
No, I think Vibhu said something like, oh, you were using LLMs to process the RAG. So was it like you were using LLMs to extract out the relevant information, or were you using like TF-IDF or semantic embeddings based on chunks?
All of them.
Both.
So we had a custom embedding, we had LLM processing. We just had like a heavy rail of guardrails instead of speed optimized. So like performance could be very, very good. But I don't know. I feel like off topic. We can just take it to this one.
Yeah.
Like John, you
Yeah,
ran
I guess.
deep research.
Huh?
You ran a deep research on distillation stuff. Just so I'm on the edge for the answer. Sorry.
I didn't kick it off because I entered it into the wrong window on Gemini.
See, this is why you pay $200. There's only one window.
It's free for me.
Must
Show
be
off.
nice, bro. Free GTC, free deep research. It must be.
Hey, I get feedback, okay. Okay.
All right, man. See you guys next week.
See you guys next week. Thanks, everyone. Bye-bye.